Namaste and welcome to CADEC learning series. In this video, we'll see example of fabricated structure for manufacturing drawing configurator. We'll use this girder assembly for the demo. It has got a box structure and different stiffeners, baffle plates, end carriage, end plates and fins. This is the agenda for this video. We'll see it one by one. First of all, we have used a bottom-up approach. The advantage is getting the bill of material in the way we want. Second advantage is the flexibility in doing combinations of shapes, features, and components. And that is a very useful advantage in the long run. Some extra work which is required for for bottom-up approach is that uh, some assembly features uh, need to be created in different parts. For example, the uh, side and top cut which is required in web plate, we need to add a cut like this, and slant cut is required to be added like this in this particular part. Similar features are required in other components also. So if we see the bottom plate, here also we have a side cut and slant cut. So some extra work is required for bottom up approach, but that is useful in the long run in terms of control and flexibility. Uh, we'll see the shape variation used in this particular assembly. Girder sits on top of two end carriages. So by default, the mounting is top mounting. If the sufficient clearance above the end carriage is required, if the clearance is not there, then we need to move the girder slightly below. So we need a top and side mounting. And if the girder height is still more, then we may need slanted cuts at the bottom. Now we'll see the design calculations. This is the variable table, and various design calculations are defined here. The important design calculations here are the thicknesses of different plates and widths of different flanges. So the design calculation is based on a lookup table which is shown here. This is lookup table for duty class M4 to M6, and for different loads, for different spans, what should be the end carriage width and height, and the girder web thickness, height, flange width, and bottom plate thickness and top plate thickness is given here. So in CADEC, we can define a lookup table for this. In this case, we will use a different approach of using defining a user function. So here, if you see this web height, you will see the expression is fun underscore get EC and GR sizing. That is the end carriage and girder sizing. Uh, and the inputs are span, lifting load, and class of duty. So we'll see what is this get EC and GR sizing function. So we'll go to user functions. We'll choose the user function. This is written in simple English like language in JavaScript or C sharp uh, syntax. Uh, you need to know Some programming functionalities like loops, arrays, how to define variables and use variables as required. Uh, so in this way, the function can be defined, and once the function is defined, you can use it uh, in various ways very easily. So here in this example, the same function is used for finding out different parameters by passing on different counter variables. Similarly, calculations are required for finding out the pitches. We'll see driven shape here. Uh, Driven shape is the uh, size calculations driving the shape variation. So the shape variation of top side and slanted is calculated based on the height of the end carriage and girder and top clearance. The different parameters are linked to different calculated variables like this. This is the size linking. We'll see the shape linking before that shape variables. So end connections are top side and slanted, and class is M1, M3, M4, M6, and 7, 8. And the mandatory functionality is shown here. For example, in web plate, the first four features are always required, but the top and side cut and the slant cut is required only when that functionality is enabled. And that brings us to make optional. So in end connection top and side, we'll say that in the web plate, the top and side cut is added, and in bottom plate again, cut side top is added. In the end plate again, top side cut is added, and side fin plate again, top side cut is added. And in slanted, we'll see that the top side and slant both cuts are added in the different parts. We'll also see the drawing configurator. In this example, I only added one drawing, but there can be multiple drawings. I've created a GA drawing showing some of the individual component details. So this is the front view, side view, and top view. I have a isometric view and a detail and a section view showing the baffle plate details. Though there are five views here and one bill of material, we want to club them in three different subgroups. One is this, second is this, and third is this. So how we have defined that in CADEC is by defining subsheets. So in subsheet M1, we'll see that view 1, 3 and 1, 3 and 2 are defined in one group. This extra drawing view 4 is the view 4 is this view is defined as a extra drawing view, and its xy position is defined, and scale factor is also defined. For the same view, we also tell CADEC to add auto balloons in that view. For that subgroup, we have defined what are the left, right, top, bottom margins to be used so that that particular subgroup of views can be located and scaled. Then we have subgroup 2, which is M2, in which we have only used the section view A. So this is section view A. So that subgroup is at the bottom, and different top and bottom and right margins are specified for that. So we'll create some output and check the use of this configurator. So I'll choose gear assembly, girder assembly. I'll specify some layout ID. Let's say I'll choose M4 class. Then lifting load is, let's say, 7 ton. Span is 12 meters. Available height above the rails is, let's say, 1500, and end carriage length is, let's say, 2500. So we'll see if the design calculations are done properly. So in this case, uh, end condition is automatically chosen as slanted. If I increase the height, let's say 3000, the height above the rails, then the end condition may change. In this case, it is top. If I reduce it to, let's say, 2500, it is still top, maybe for 2000. For 1900, it is slanted. Or maybe for 2200, it became top and side. And for, let's say, 1800, it has become slanted again. So the calculations are automatically done by CADEC. We'll see how the geometry is updated. So the different features are enabled and we get our geometry. Now let's generate the manufacturing drawings. So the drawing is updated, scaled, dimensions are moved, and we get our drawing with the required bill of material. The weight is updated, the layout ID is updated, the specifications are updated. That's all. Thank you.